Welcome back, fellow nerds. In today's video we will talk about motion. Specifically we will talk about constant acceleration. Now in the previous videos, the motion we've talked about were usually formulas that had to do with constant speed, velocity and stuff, but in today's class we'll talk about acceleration. All right, so under constant speed, we firstly acceleration would define acceleration as change in velocity with time. Now we talked about velocity and speed being similar in magnitude, literally being the same in magnitude, except velocity is a vector, speed is a scalar, and that is why velocity has got direction while speed does not have. Okay, so under velocity we discovered that in traveling under velocity or speed, we had discovered that in traveling longer distances, usually our speed was not a constant because of the circumstances. The road, you could have been slowing down and be making instantaneous speeds or velocities, right? Because then you'd have slowed down. You probably was at 40 meters per second. You see somebody traveling, you slow down to 20 and that. So we discovered that for a distance, it was advisable to find an average, right? An average velocity or an average speed. And as such, we are going to use a more mathematical way of finding average speed by saying initial average speed plus the final speed, or rather velocity, divided by 2, right? You just this can also be written as v initial plus v final over 2. All right, this just signals that the 2 divide. This is a typical formula for finding average. Okay, all right, so this is one equation we are going to get. Okay, then we also discovered speed is distance over time. All right, so these were formulas that we had discovered. Okay, so since we are saying acceleration is change in velocity with time, we are going to say acceleration will be final minus initial over time. All right, so we can also rewrite that as acceleration is equal to final minus initial over time. All right, so these are the equations that we have, this and this. We also have speed is equal to distance over time, right? These are the simple equations that we have. Okay, now under constant accelerations, the equations that we use. Okay, so firstly, equation number 1 is v is equal to u plus at. Equation number 2 is equal to v squared. All right, so the other equation is v squared is equal to u squared plus 2as, and the other equation is going to be s is equal to ut plus half at squared. Now we know what u means. This is just initial velocity, which can be denoted as v initial. Okay, so these are the equations of motion under constant acceleration. All right, so how do we derive these equations? Okay, so we start with the small equations that we had talked about. All right, so for the first one, we are going to say, since acceleration is equal to v minus u over t, right, you can just say you cross multiply, you have v minus that is equal to a plus t. Then if you're finding velocity, we'll say at plus u, which you can write as u plus at. This will help you find velocity under constant acceleration. So if you are given a question, or if you're analyzing motion at constant acceleration and you are told to find a certain velocity, you would use this equation. These are equations that help us find values under constant acceleration. All right, so let's look at the second equation. V squared is equal to u squared plus 2as. All right, so what are we trying to find? We're trying to find v squared, right? Okay, we are trying to find what equation? V squared is equal to u squared plus 2as. Okay, so what do we have in this equation? We have velocity, we have acceleration, and we have distance. Okay, we can use this equation to help us derive that. Okay, so we'll say v is equal to u plus at. All right, so v squared is equal to u squared plus. All right, so in this equation we have acceleration, we have inertia, we have final. We do have time, we don't have time. All right, so we're trying to put this is distance, right, into this equation. Okay, so how are we going to do that? All right, so we are going to, so in the equations that we have had, all right, we have in the equation that we had earlier, we had s is equal to that. So we are going to say, so firstly, speed is equal to distance over time, right? So we can say, okay, we can say a distance is equal to s over s multiplied by t, right? When you cross multiply, all right? So distance is equal to, this is your speed. And from our previous equation, we found that speed, which is average speed, but average speed and speed is similar, so we can replace them in the same equation. All right, so we have something that looks like this now, right? This denoting that speed. Okay, so this is the distance. Now this is the time. Now here under time we are trying to put an equation that has got distance in it, so we'll replace t by variables that have distance in them. Okay, so this will help us, right? So from here we can say d is equal to u plus v multiplied by t over 2, right? So we're going to now cross multiply. We'll have 2d is equal to u plus v t, right? Then you're going to have u plus v over u plus v. You cancel out. You have t is equal to 2d over u plus v. So this is your t, right? And it has distance in it. That is what we are going to replace in this t on top. Okay, so in the equation, v is equal to u plus at, we are going to replace that t with this, right? So that whole t would denote 2d over u plus v. Okay, and in that case we're going to have u is equal to u plus, so when you're multiplying, you're always multiplying the value on top, right? So a is multiplying 2d, so we're going to say a multiplied by 2d will give you 2ad, all right, over u plus v over 1. Now since we are trying to find v squared is equal to u squared plus 2as, we can try to solve this, right? So common denominator there is u plus v. You do that. So 1 into u plus v is u plus v, so you have u multiplied by u plus v, okay, plus u plus v into u plus v, that is 1. You multiply 1 by 2ad, will just give you 2ad is equal to v. All right, so now you cross multiply again, so you have v multiplying u plus v is equal to u plus v plus 2ad. All right, so v will give you uv plus v squared is equal to u squared multiplied by uv plus 2ad. All right, so you have now v squared is equal to u squared plus uv. This can change side, and so if it changes side, it changes sign, right? So you can say this is positive, it goes this side, it becomes a negative. Okay, this is how I just used to remember it, why I say change side, change sign, taught by my math teacher. Okay, well, we continue, plus 2ad. All right, so you have v squared is equal to u squared. This is going to cancel out, plus 2ad, which you can still write as u squared plus 2as, same thing. All right, this gives us equation number what? Number 2. All right, okay, so we move on to the third equation, okay, which is s is equal to ut plus half at squared. All right, so what are we looking for here? Distance. We already have one that denotes distance, right? We had found out this, right? Which you can replace this with s, either way it will denote distance. Okay, but x or d is usually common, but s also applies. All right, so we are going to, since we're trying to find this, and we have that s which is denoted distance. All right, so we are going to say s is equal to, or we can say x, because it is usually common to say x, is denoting is equal to all right, so in this equation we have acceleration, time, and distance itself. Okay, so we are going to use our small equations to help us find this equation. All right, so what are we going to use? Okay, so we have distance, right? But in this distance equation we have u, we have v, we have, okay, so we have time, all right, which is okay, we have u, which is okay, but we have v. But in this equation we don't have v, so we're going to replace v with something. Okay, so what is our v? We already had an equation that has a v in it, so we can replace this whole thing to denote v. Okay, so we are going to say, since our distance is equal to u plus v over 2 multiplied by time, we are going to say distance is equal to u plus, what is our v now? Our v is now u plus a t over 2. Okay, so you do that multiplied by t. Okay, so now we have d is equal to u plus, so u plus a t. Okay, this will multiply t over 2. All right, so when you have d is equal to, this t will multiply all the items inside, right? So t multiplied by u will give you ut plus u. All right, so in fact, before we go that, like, okay, but before we go and complicate things, I think we can just do this. All right, so we can, since u is common, it could help us add things there, right? So let's take it out of the bracket. So say positive multiplied by u will give you positive will give, so it's like positive times u. This is like positive 1 times u will give you positive u. Positive 1 multiplied by positive 80 will give you positive 80, right? This whole thing multiplied by t over 2. Okay, so now d is going to be u plus u will give you what? 2u plus 80 multiplied by t over 2. All right, actually this whole 2 is divided into one thing. All right, so you have d is equal to 2u plus 80 over 2, right? This is like this, then multiplied by t. Okay, so this, so you can rewrite this, or you can go directly and multiply, or you can write this mathematically. This is the same as tu over 2 plus 80 over 2 multiplied by t, right? All right, so having written it like this, we can now cancel the 2 there, because written like this, the common denominator will be 2 into 2, 1. You get back to that. All right, so 2 can cancel. All right, so now you have u plus a t over 2. This is multiplying t now. Okay, so now we have t multiplied by both sides, right? So t multiplied by u will have ut, all right, plus t multiplied by 80 over 2 will have at squared over 2 is equal to d. All right, so d is going to be ut plus since you can isolate the 2, because this just simply means 1 multiplied by 80 squared over 2, which you can write as ut plus half a t squared is equal to d. And so d, which can also be written as s or x, will denote ut, or x will denote ut plus half a t squared. This is equation 3. Okay, so now we have found all the 3 equations that help us find other variables when it comes to questions to do with constant acceleration. All right, so having learned those, okay, so in case you forget or you don't memorize, because I definitely disagree on memorizing, so if you ever forget, you can literally derive these equations on your own. All right, and so we are going to write them like that. So we have this. Okay, so we have this is equal to ut. In fact, we can say x is equal to ut plus half at squared.